Hello! Today I will be presenting my project, Streamlining Scheduling with Simulated Annealing. This project all started with a problem I found at my job. I noticed that every week my managers would manually arrange the schedule for our dozen or so employees. This was very inefficient and a time-consuming part of their job. While I watched them struggle through this, I thought to myself that an algorithm could do that job much more efficiently than doing it manually. Starting with that idea, I set out on the project with the goal to design and program an algorithm that quickly and effectively generates employee schedules for businesses. I came up with the idea of using simulated annealing to solve this problem entirely by chance. Occasionally, I look into random algorithms or interesting quirks of computer science in a fairly superficial way, just to learn more about something I'm interested in. A few days before I sat down to come up with science fair ideas, I happened to stumble upon simulated annealing. At first, I didn't even realize I could use it to solve this problem, but it clicked in my head a couple of days later. I didn't realize I could use simulated annealing right away because it is a somewhat contrived algorithm. You can read more about it in my document, but on the most basic level, simulated annealing is an optimization algorithm designed to parallel the effects of a real chemical process called annealing. Simulated annealing borrows the fundamental properties of annealing and implements them in an abstract way that takes some time to fully understand. Once I had decided to use simulated annealing for my project, I got to work on actually implementing this algorithm. The first step to accomplish this was abstracting the problem to some function that could be optimized, as it is an optimization algorithm. My function scores a given employee schedule based on how closely it gives the employees the number of hours they requested. The further from the requested number, the lower the score for the schedule. I designed the rest of the algorithm to maximize this function. Once that was set up, I had to generate an initial schedule for the algorithm to work with and change over time. This turned out to be more difficult than I thought because I had to make sure the initial generation wouldn't throw an error if invalid shift schedules were put into it. Next, I had to generate random neighbor states for the algorithm to move between. Once the initial state is generated, most of the edge cases have been taken care of, so neighbor state generation is easier to accomplish. The most important part of neighbor generation, though, is making sure that neighbors are both completely random and similar enough to the current state to provide continuity. Once this was done, I was able to more or less copy the rest of the general equations and values for all simulated annealing implementations to finish my own. Once I had finished setting up the algorithm, I tested it with 10 example employees and 37 shifts spread across a 7-day week that I based on my own experience at work. I intentionally designed the shift schedule to have too few hours to fulfill all of the requested hours, so the algorithm would have to deal with an imperfect situation. With these test data, I ran through 100 tests, tracking score and runtime. The algorithm ran better than even I expected it to. Across these 100 tests, the algorithm was very close to the ideal score, more than 90% of the time, and it averaged a runtime of less than a second. The goal of this project was to design and program an algorithm that quickly and effectively generates employee schedules for businesses. Based on this outcome, the program verifiably reaches the standards of both quick and effective, clearly accomplishing the goal. This program could definitely be used in businesses today, but there's still more I can do to make it better. First and foremost, this program needs to be encapsulated in a website that can deal with its input and output. I originally planned to make the website myself, but it proved to be too much for one person to handle. Thank you for listening to my presentation.